Hey Earth Science, this is Chapter 19, Section 2, Features of the Ocean Floor. Now this section contains a lot of terms and definitions, which means that this video is not much more than me reading the textbook to you in a summarized form. So if reading the textbook is just as good or better for you, then you might as well just skip this video and go straight to that. But if you are an auditory learner, or you just like to have me tell it to you because, I don't know, you miss me or something, then please enjoy. Let's go over the objectives for Chapter 19, Section 2. First, describe the main features of the continental margins. And second, describe the main features of the deep ocean basin. Okay, so let's get into it. Features of the ocean floor start with the continental margin. That is the shallow seafloor that is located between the shoreline and the deep sea bottom. The deep ocean basin is the part of the ocean floor that is under deep water beyond the continental margin and that is composed of oceanic crust and a thin layer of sediment. The ocean floor can be divided into two major areas. So if you were starting on the continent and walking out to sea for some reason, first, as you go under the water, you'd be walking on the continental margin, and eventually you'd end up walking on the deep ocean basin. I do not recommend that you walk out to sea. Right, so the line that divides the continental crust from the oceanic crust is not abrupt or distinct. It's not like some line that you could trace and just step over it. It's a fuzzy line. Shorelines are not the true boundaries between the oceanic crust and the continental crust. If you walk out into the ocean some and you're underwater, but the water's not that deep, you're still walking on continental crust. The boundaries are actually some distance offshore and beneath the ocean and the thick sediments of the continental margin. So continents are outlined in most places by a zone of shallow water where the ocean covers the end of the continent. The part of the continent that is covered by water is called the Continental Shelf. You might think of it like the continent has its toes in the water. That part under the water, under shallow water that is called the Continental Shelf. The shelf usually slopes gently from the shoreline and drops about 0.12 meters every 100 meters. Okay, so the average depth of the water covering a continental shelf is only about 60 meters. It's a little bit less than 200 feet. And although it is underwater, a continental shelf is part of the continental margin, not the deep ocean basin. Okay, just a reminder that we're still on continental crust here. Changes in sea level affect the continental shelves. As you might imagine, it's right on the shoreline, which means that if the water level goes up or down a little bit, it could extend or retract the continental shelf. So the Continental Slope and the Continental Rise are up next. At the seaward edge of a continental shelf, there's a steep slope where it drops off suddenly that is called a continental slope. The continental shelf and continental slope may be cut by deep V-shaped valleys, and these deep valleys are called submarine canyons. So other canyons may form over time as very dense currents called turbidity currents carry large amounts of sediment down the continental slopes. Turbidity currents form when earthquakes cause underwater landslides or when large sediment loads run down a slope. These sediments form a wedge at the base of the continental slope called a continental rise. So in order, as you're walking out from the beach to the ocean, you start on the continental shelf, and as you come to the end of the continental margin, as you're on the continental shelf, that steep drop-off is called the continental slope, but at the bottom of the continental slope is a continental rise where it is more gradual, and finally you're out on the deep ocean basin. So this picture is a good diagram of that. I'm going to be making my own diagram for you, so you should be able to find this picture in the book, and you can look over it, but you should see what I saw. You should see what I said, that it goes beach, then continental shelf, followed by continental slope, and then a continental rise, all of that is the continental margin, and past that, you're out on the deep ocean basin. So let's talk about the deep ocean basins some. They also have distinct features. They include broad, flat plains, submerged volcanoes, gigantic mountain ranges, and deep trenches. Okay, so in the deep ocean basins, the mountains are higher and the plains are flatter than any features found on the continents are. Right, so deep ocean basins continued. We have trenches as one of the features. So trenches are a long, narrow, and steep depression that forms on the ocean floor as a result of subduction of a tectonic plate that runs parallel to the trend of a chain of volcanic islands or the coastline of a continent, and that may be as deep as 11 kilometers below sea level. They're also called an ocean trench or a deep ocean trench. Earthquakes occur near trenches. Volcanic mountain ranges and volcanic island arcs also form near trenches. So you might think of a trench almost like it was a valley on the land. Well, that's a good image to have in mind. They're very, very different. So a trench forms when you have two oceanic plates that converge and then one of them subducts and it kind of drags down a little bit. Now that little drag down, the two that are getting pulled in there, that is the formation of a trench. And as it says, they can get extraordinarily deep. Okay, next feature, Abyssal Plains. So an abyssal plain is a large, flat, almost level area of the deep ocean basin. They cover about half of the deep ocean basins and are the flattest regions on Earth. Layers of fine sediment cover the abyssal plains, and there are a couple factors that determine how thick those sediments are. The next feature is mid-ocean ridges. So the most prominent features of ocean basins are the mid-ocean ridges, which form underwater mountain ranges that run along the floors of all oceans. Mid-ocean ridges rise above sea level in only a few places, such as in Iceland, and fault-bound blocks of crust that form parallel to the ridges as the lithosphere cools and contracts are called abyssal hills. As mid-ocean ridges adjust to changes in the direction of plate motions, they break into segments that are bounded by faults. And these faults create areas of rough topography called fracture zones, which run perpendicular across the ridge. Next up, seamounts. Seamounts are submerged volcanic mountains that are taller than 1 kilometer, and they form in areas of increased volcanic activity called hotspots. Seamounts that rise above the ocean surface form oceanic islands. And as tectonic plate movements carry islands away from a hotspot, the islands sink and are eroded by waves to form flat-top, submerged seamounts called guyots or table mounts. This picture should show you basically the same thing that the last one did, except this one doesn't have labels, but this one does illustrate a mid-ocean ridge. You can see how the magma comes up there, and that's actually where new oceanic crust will form. All right, well, that's section 2. Please look out for the other video, which is going to be more instructive on this section.